When x tends to certain point, the value of f of x also reaches to the limit value. For all the values less than 0, your limiting value is -1 or the functional value is -1. We have essentially two ways of approaching 0. One is from the left side and another from the right side. As x approaches to 1, nearer to 1, the value of the function is also equal to 1. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. I'm starting today with the new chapter called Limits and Derivative. So let me give you an introduction about limits. So in today's class, we will be discussing what do you mean by limits. So limits, what do you mean by limits? Suppose we have a function. It is defined at certain point. But what do you mean by limit? So to give a better clarity for limit, I'll take an example. Let us take a function f of x is equal to x square. Suppose I take any point at x is equal to 0. At x is equal to 0, clearly the function is defined. Defined means its value is also equal to 0. That is f of 0 square is 0, f of x is 0 at x is equal to 0. So the graph of the function will be like this. It is a parabola. So clearly at this point the value of the function, this y is equal to x square. We also take f of x as y is equal to f of x, which we have studied in relations and functions. So y is equal to x square is 0 at x is equal to 0. Now if I take a values very near to 0. Let me take the value of x near to 0. So I can approach from two sides. One is from the right side, another is from the left side. So if I take the value of x near to 0, so x is near to 0, we use the word as tends to 0 or close to 0. So when the value of x approaches to 0, so the value of f of x also comes down here. So you can see, so this is the value of f of x which also comes closer to 0. Similarly, when you take the value from the right side, that is x approaches to 0 from the right side, the value of f of x also comes to 0. Suppose you take any point, for example, f of 0.2. So what is the value? It is 0.04. It is approximately equal to 0. Similarly, if you take any point here, for example, f of minus 0.1, which is again 0.01. So which is again almost equal to 0. So as the value of x approaches to 0 or near to 0, the functional value is also equal to 0. So this is what the limiting concept. So the functional value is almost equal to the limiting value. So when x tends to certain point, the value of f of x also reaches to the limit value. That is written in the form of as x tends to certain point A. We say it as any point. In this example, we have taken that point as 0. As x approaches to 0, the functional value or the limiting value is always equal to the functional value f of x. As I take at x is equal to 0, f of x is 0, and as x reaches 0, that is very close to 0, the limiting value is same as the functional value. Then we say that limit of a function exists and we write it as limit as x tends to a, f of x is equal to L, where L is called as the limit of the function. For example, here we can say 0 is the limit of the function at the point x tends to 0. I'll take one more example. Let me take a modulus function. F of x is equal to modulus x, where x is not equal to 0, I'll take. Let me give a condition. So how the graph of the modulus function? We know the graph of the function is like this. But the function is not defined at x is equal to 0. So we'll write an open circle here, because at x is equal to 0, the function is not defined. Whereas for all the negative values, the value of the function is positive, and for the positive values of x, again it takes the value of positive y-axis. Now, if I take a point like 0.1, 0.001, 0.5 like this, as x comes near to 0, the value of the function also comes near to 0, and as x comes near to 0 from the left side, here also the value of the function is almost close to 0. So therefore, here also the limit of the function exists where the functional value is same as the limiting value. And as I said, note that we have essentially two ways of approaching 0. One is from the left side and another from the right side. So we say the limiting value as x approaches from left side, we'll write it as x tends to a minus. Minus implies we are taking the value near to the given value from the left side, and the limiting value from the right side, we'll write it as x tends to plus. So when these two are equal, that is, we called it as left hand limit and we call it as right hand limit. When left hand limit is equal to right hand limit, we say the limit of the function exists, and then we write the limit of a function f of x as x tends to a is equal to f of a. So f of a is nothing but your L, as it is the value. So for the given point, the limit of the function is same as the functional value. Then we say that limit of a function exists. That is when LHL is equal to RHL. Left hand limit is equal to right hand limit. Now, as I said, the meaning of x tends to a. X is a variable, a is a constant. We take a is any point on the x-axis. So a is a constant. So since x is a variable, we can change its value. Whatever the variable is there, we can change the value. So it can be changed in that the value comes nearer and nearer to a, nearer and nearer to a. So that is symbolically we write it as x tends to a or x close to a. Next, here I have taken an example to study whether the limit of the function exists or not. So, investigate the behavior of the function f of x is equal to x square minus 4 by x minus 2 at the point x is equal to 2 and near the point x is equal to 2. So, let me take this function f of x is equal to x square minus 4 divided by x minus 2. Let me define the function at the point x is equal to 2. What happens at x is equal to 2? So, at x is equal to 2, it is 0 by 0, which is an indeterminate form, which is not defined because the denominator cannot be equal to 0, which is an undefined, or we say it as indeterminate form. So, thus we say that f of 2 is not defined. So, we write therefore f of 2 is not defined. Now, let us see for the points nearer to 2. Nearer to 2 means like 1.999 or 2.001, almost equal to 2 values. Let us see whether the function exists or not. Now, before that, so the function is an indeterminate form. So, whenever the function is an indeterminate form, just convert so that the value get cancelled. We can write x square minus 4 as x plus 2, x minus 2 divided by x minus 2. So, cancels those. Therefore, the function can be rewritten as x plus 2. Now, the function is defined. So, let us see for what values whether the values becomes equal to the functional value as x is equal to 2. Now, let us write the graph. So, if I take, since this is x plus 2, so it is a straight line. Now, here we can see, so f of 0 is 2, so this is 0 and this point is 0, 2. And they have given x is equal to 2, we got that f of 2 is not defined. So for x is equal to 2, that is 2 comma 0. So the point here it is not defined. So I'll write an open circle there. So this is actually the point 0 comma 4. So here the function is not defined. Now, so the function is not defined at x is equal to 2, whereas it is defined for all other values because it takes the form of f of x is equal to x plus 2. Now, let us take the values nearer to 0. So, let me take the values. I'll write the graph once again. So, this is the graph. So this point at x is equal to 0. This is the point 2 comma 0. So here the function is not defined. So I'll write an open circle there. So this point is 0 comma 4 and this is 0 comma 2. This is actually minus 2 comma 0. So this is the function. Now take the values close to 2. So I said we can approach from two sides. One is from the left side, another is from the right side. So let us take the values of 2 from the left side now. So if I take the value as f of x, very clear. Let me take 1.9. Then the function is actually f of x is equal to x plus 2. So if I take 1.9, your answer is almost 3.9. If I take 1.99, it is 3.99. If I take 1.999, answer is 3.999, which is almost equal to 4. Similarly, let me take the values of x from the right side, which is very close to 2. So let me take 2.001. Your answer is almost 4.001. So 2.01, it is 4.01. So 2.1, 4.1. So almost your left hand value and right hand value is equal to the functional value at 4, that is 4 at x is equal to 2. So it is very clear that as x goes closer to 2 from both the sides, whether from the right side or from the left side, the functional values go nearer to 4. Therefore, what we say, the limit value as you go from the left, we write it as 2 minus, is same as the limit value as you go from the left. So that is equal to 4. So therefore, here the limit of the function exists because your left hand limit and right hand limit takes the value which is same as the functional value when x goes nearer to a, either from right or from the left. Now, let us study the definition of limit of a function. So, limit of a function. Let f of x be a function defined on an interval which contains a point x is equal to a. It may be defined at any interval, but that interval contains a point a except possible at x is equal to a. Then we write or we say that limit f of x as x tends to a equals to L, where L is called the limit of the function, which is symbolically written in the form the same as the previous one, that is limit f of x as x tends to a equals to L, and L is called the limit of the function f of x. Discuss the function f of x is equal to minus 1 when x less than 0 and 1 if x greater than 0 at x is equal to 0. They have given the point. We have to discuss whether the limit of the function exists or not. So let us write the graph for this. Here, for all the values x less than 0, f of x takes the value minus 1. For all the values greater than 0, f of x takes the value 1, and clearly it is not defined at x is equal to 0. So the graph of this function will be like this. If this is the point 0, for x less than 0, the value is minus 1. So for all the values, here I'll write an open circle. This is minus 1. Here again I'll write an open circle. This is plus 1 because at 0 the function value is not defined. So this is for all the values of x, and this is for all the values of x in negative x-axis. So x dash, x, y, y dash. Now see, let me take a value of x approaches to 0 from your right side. It approaches to 0 as it goes near to and near to 0. Okay, that is limit x tends to 0 plus. The function is clearly defined for all the values x greater than 0, the value is 1. So therefore, the limit as x close to 0 from the right side, the value of the function is 1. Now let me take the value of x close to 0 from your left side. So from the left side, for all the values less than 0. So this is 0. For all the values less than 0, your limiting value is minus 1 or the functional value is minus 1. So therefore, as x approaches to 0 from your left side, the functional value is minus 1. So clearly you can see the left hand limit is not equal to your right hand limit, because right hand limit is 1 and left hand limit is minus 1. Also, the function is not defined at x is equal to 0. So therefore, we say limit does not exist. So clearly we can see from the graph, the limit of the function does not exist. So now here discuss the limit of the function f of x plus 10 at x is equal to 5. So here we can take a function at x is equal to 5, the function is defined. So let me take the point as 0, somewhere here 10, 20, 30. I'll take this as 10, 20, 30. So at x is equal to 5, the value will be equal to 15. At x is equal to 10, the value will be equal to 20. So for 0, it is 10. So it goes like this. Now I have to take, so this is the value f of x is equal to 15 at x is equal to 5. So this point now, let us see the value close to 5 from the left side as well as from the right side. So let me take the values x and f of x. As x close to 5 means I take the very values very nearer to 5. Let me take 4.9. Then f of x is 14.9. 4.99, it is 14.99. 4.999, then it is 14.999. So almost equal to 15 again, which is same as the functional value. Now let me take from your right side. So x right side means 5.01. Let me take 5.01. Very close to 5 you should take f of x. Then your answer is 15.01. 5.001, 15.001. 5.0001, then it is almost 15.0001. So from both the sides, the value of the function either from the left or from the right is same as the functional value, that is f of x is equal to 15. So at x is equal to 5, f of x is equal to 15. Also your left hand limit and right hand limit is same as the functional value. So your left hand limit almost approaches to 15, right hand limit is also approaches to 15. So what I can conclude here, so therefore limit of the function exists, that is limit as x tends to 5, f of x is equal to 15, we can conclude, that is limit of the function exists, because your left hand limit and right hand limit is same and it is equal to the functional value. Next we have a function, limit of a function f of x at x is equal to 1. So at x is equal to 1, limit as x tends to 1 minus and limit as x tends to 1 plus. That is f of x and f of x. What happens now? So let us take the value very closer to 1. So let me take x and f of x here. So this is for your left hand limit. So let me take before 1. So that is 0.9. then your value will be 0.729, which is almost equal to the functional value. So f of 1, that is 1 cube, is 1. So at x is equal to 1, f of x is also 1. So now let me take 0.99. What is the value? 0.99 whole cube, 0.97029. And similarly, when you take almost very closer values, you will get the values which is close to 1 again. So let me take a point from your right hand side. So after 1, that is x and f of x. So let me take 1.01. So the value of 1.01 whole cube will be 1.030301. If I take 1.1, the value is 1.331, which is almost equal to 1. So your left hand limit is also 1 and right hand limit is also 1. So therefore what we can conclude, LHL is equal to RHL. So therefore the limit exists. Therefore what we can write, limit of a function as x tends to 1, f of x is also equal to 1. As x approaches to 1, nearer to 1, the value of the function is also equal to 1. Therefore, we say limit exists. Yes, I hope you understood the concepts of limit. We'll take few more examples in our next session to study in detail about limits. Until then, keep watching, keep learning and keep exploring. Thank you.